Download this code from codegive.com, link in the description below. OK, let's dive deep into the Snykcon CTF challenge involving a random flag generator with a weak prng seed. This will be a comprehensive tutorial covering the problem description, the vulnerability, the exploitation strategy, and a detailed code example in Python. Challenge context **. Often, CTF, capture the flag, challenges involving random number generation focus on weaknesses in pseudo-random number generators, prngs. These generators aren't truly random, they produce a sequence of numbers based on an initial seed. If the seed is predictable or can be derived, the entire sequence of random numbers can be recreated, allowing you to predict, in this case, the flag. A common vulnerability arises when insufficient entropy in the seed the seed isn't random enough. For example, using the system time with low precision, seconds or milliseconds, is easily guessable. Seed reuse the same seed is used multiple times. Weak prng algorithm some prng algorithms are inherently easier to predict than others, even with a good seed. Example: linear congruential generator, LCG. In a Snykcon CTF context, we can expect the challenge to be well designed with realistic scenarios, so the prng may be something common and implemented in the target language. General vulnerability pattern *. 1. A server-side application, example a web service, generates a flag based on pseudo-random numbers. 2. The prng is seeded with a predictable or guessable value, example a timestamp, a user ID, or a combination. 3. You observe some output from the server that is dependent on the random numbers. This allows you to correlate the observed output with possible seeds. 4. You try to calculate the original seed and rerun the generation function with that calculated seed to generate the same flag. Let's create a hypothetical scenario and solution. Let's assume the CTF challenge presents a web application that provides random flags upon request. Let's say the backend application uses Python and generates a random flag, but the server seeds the random number generator using the current timestamp. Hypothetical scenario *. 1. Challenge description *. The web app allows you to request flags. Each flag should be unique. 2. Observed behavior *. You notice that the first few characters of each flag change much more rapidly than the last few. You suspect the flag is generated with a prng seeded with the current time. Moreover, the server returns the timestamp used to generate the seed of the flag. The weakness *. The random module in Python, using the Mersenne twister algorithm, is a prng. If the seed is known, the entire sequence of random numbers it will produce is deterministic. The weakness is that the server gives you the seed it uses to generate the flag. Exploitation strategy *. 1. Capture a timestamp and corresponding flag *. When you request a flag, note the timestamp and the flag that is generated. 2. Replicate the flag generation *. Use the same timestamp as the seed for your local random number generator. Rerun the flag generation logic on your machine. You should generate the exact same flag as the server. Detailed code example, Python. Here's a Python script that simulates the vulnerable server-side code and the exploitation. Explanation *. 1. Generate _flag, timestamp, *. This function simulates the server-side flag generation. It takes a timestamp as input, seeds the random number generator with that timestamp, generates a 32-byte random sequence. It then hashes the sequence to generate a flag. This is a common pattern, using randomness to create unique identifiers or keys. 2. Get _flag_from_server, This function simulates requesting a flag from the server. It gets the current timestamp, calls generate_flag, to create the flag, and returns both the flag and the timestamp. This is crucial for the exploit. 3. Exploit, timestamp, *. This function represents the attacker's code. It takes the captured timestamp from the server, seeds its own random number generator with the same timestamp, and then replicates the same flag generation logic. 4. If __name__= __main__:, the main block simulates the entire process. It requests a flag from the server, prints the timestamp and the flag it received. Then, it calls the exploit function to regenerate the flag using the timestamp. Finally, it compares the server's flag with the attacker's flag to confirm the exploit was successful. How to run the code *. 1. Save the code as a Python file, example Snykcon_ctf.py. 2. Run the script from your terminal, Python Snykcon_ctf.py. You should see output indicating that the attacker's flag matches the server's flag, demonstrating the successful exploitation. Important considerations and variations *. Timestamp precision *. The accuracy of the timestamp is critical. If the server uses a timestamp with microsecond precision and you can only get second precision, you'll need to iterate through all possible microseconds within that second. The exploit becomes a brute force attack over a small number of possibilities. Additional data in the seed *. The server might use a combination of data in the seed, like the timestamp and a user ID or a session ID. You'll need to identify how the server generates the seed to replicate it. Time synchronization issues *. If there is a significant difference between the server's clock and your clock, even microsecond precision might not be enough. You might need to try timestamps a few seconds before and after the time you think the server used. Hashing *. The example uses hashlib.sha256 for demonstration. The real challenge might use a different hashing algorithm or encryption. You'll need to adapt your code accordingly. The key is to exactly replicate the flag generation logic. More complex prng usage *. The challenge might involve using the random module in more complex ways, such as generating a sequence of random indices to select characters from a base string. You would need to analyze the code carefully to understand how the randomness is used. Network communication *. In a real CTF, you would not have access to the server-side code. You would need to interact with the server using HTTP requests, example with the requests library in Python, and extract the necessary information, timestamp, flag, etc., from the server's responses. Generalized exploit template, Python with requests. Key improvements in the template *. Requests library *. Uses the requests library for making HTTP requests. Make sure to install it, pip install requests. Error handling *. Includes basic error handling for network requests and JSON parsing. JSON parsing *. Assumes the server returns data in JSON format. Adjust the parsing logic as needed, example if the server returns HTML or plain text. Flexibility *. Replace URL with the actual endpoint, and adjust the parsing logic within get_server_data, based on how the server returns the flag and timestamp. Debugging tips *. Print statements *. Use print statements liberally to inspect the values of variables at different points in your code. This is essential for understanding what's happening and identifying discrepancies. PDB debugger *. Consider using the Python debugger, PDB, to step through your code line by line and examine the state of variables. This is particularly helpful when dealing with complex logic. Diff tools. If the flags are similar but not identical, use a diff tool, like diff on Linux or a visual diff tool in your IDE, to compare the strings and identify the differences. This can help you pinpoint errors in your code. Network inspection. Use your browser's developer tools, network tab, or a network proxy, like Burp Suite, to inspect the HTTP requests and responses between your script and the server. This can help you understand how the server is behaving and identify any unexpected data. Practice and persistence. The key to success in CTF challenges is practice. Work through similar challenges, read write-ups of other CTFs, and experiment with different techniques. Don't be afraid to try different approaches and debug your code until you find a solution. Persistence is essential. Good luck.